there just to ensure that you guys are getting the topics. All right.
Okay.
So let me just share my screen. All right. And if at any point you hear me buffering, just let me know. Excellent. So we're gonna go back into ratios, right? What was a ratio again? Can anyone remembers? What was a ratio? What is a ratio? All caps. If I say I have something in a ratio, dash to dash, what does that mean?
The way of representing two different numbers. So I don't know how to explain it.
That's correct. A way of representing two different things, right? On a general basis. So really, it's really comparing two values. So it's representing them, but comparing them at the same time. So write this for me. A ratio is a relation. My bad. Is a relation. Let me just zoom in for you. A ratio is a relation that is used to compare, right, the sizes of two or more quantities, right? In other words, the ratio of one quantity, right, of n, and n is just a variable. Remember what variable are? There's unknown values. So the ratio of one quantity, n, to another quantity called, let's put another unknown variable, d, right, can be represented simply as n to d or n divided by d. There we go. All right, excellent. So the reason why I'm going over it, all right, I told you that we finished laws of indices, talked about the 5 main rules, right? We talked about significant figures and scientific notation yesterday, and actually we've finished the 3 topics that we were to do this term, but I don't want to just hold and just wait until next term. So that's why I started initially by giving you ratios originally, just to introduce you to it, so that if the chance came about before the term finished, we could just go into the topic. And that's what's happening now, because we finished the 3 main topics, and I don't want to wait until January to begin another topic. So I'm just going to start new topics now. Sounds good, everybody?
Yes, sir.
All right, good.
So what to say about January, sir?
Right. So I was saying that ratios actually don't come until next term, but because we finished the 3 main topics for this term, laws of indices, significant figures, and scientific notation, right, standard form, I don't want to wait until January to begin ratios. I want to just maximize the time and just start now, which is what I'm doing.
Sir, can you send me the link, sir?
No problem. So the date is 17th. I'm just sending the link.
November 17th, and only 13 more days remaining in this month.
Right, time is flying very fast.
I have a question, just like, when is going to be the end of term exams for mathematics? December 1st?
It's gonna be in the first section of December, before you go off, right? But the exact timetable isn't released yet.
Yes,
Okay. So what I'm gonna do now, just to really show you what a ratio is, I'm gonna draw it. All right, I'm gonna draw it. So let's say, for example, I have a square box. Let me just put it in blue so you can see it easier. Put it in a lighter. Here you go. I have a square box right here. All right, and let's say it contains very valuable possessions like gold, and I want to be very kind and give some of you guys virtually some gold. All right, I would need to create a ratio, right? So I would say, for example, 2 students get this amount of gold, right? Khalil gets this amount of gold. At 0 payout, everyone gets equal amount of gold. In order to do that, I need to know divide this block of gold into some parts. So first I divide it into half, right? So how many parts is this gold in now? Count the parts. 2, correct? So if I was to represent this ratio, let's say I'm giving this section to Athzura. If I was going to give this section to Athzura, what would be the ratio? So she gets half of it. So represent 1 to 2. Excellent. So this is Athzura's share. So she gets half of the block. But let's say now, out of my half, I want to give Jazeel half of my block. Let's put it now. Right? So now this section is Jazeel's. So you see now how powerful ratio is? Because I can represent this entire diagram in just 2 numbers. So if I only have half and I'm dividing that into a half again, what is a half plus a half? Or in other words, let's actually work it out. So let's say, for example, I had a half, right? So I had 1 to 2, and then I'm making that now into 1 to 2 as well. What we realize that we have now is a quarter. Is that correct? Right. So that's the power of ratios. You can get fractions or just comparing 2 values to the next to get, for example, who owns X amount of value. And in this case, who has the most out of the 3 of us? Jazeel, this is me. Let me color myself as red because teachers like red ink. I'm gonna use red. There we go. So which person has the highest ratio? Jazeel, me, or Athzura?
Athzura.
Exactly. Good. So we would represent Athzura as 1 to 2. We would represent Jazeel as a smaller ratio, for example, 1 to 3 or 1 to 4, depending on how much I would give him. All right. Okay, excellent. Let's continue now. All right. So write something. In the diagram that I just in the diagram that was drawn, right? There were shaded and unshaded regions. Matter of fact, let me go back for the drawing so I can help you to see what I'm saying. There we go. So in the diagram that was drawn, there were shaded and unshaded regions, right? Athzura shaded green, Jazeel was shaded black, and I was unshaded, right? So to get, for example, the N, we would count how many shaded regions. Let's write that. To get the amount of N's in this scenario, we count the amount of shaded regions. Okay? What do you think we're gonna do if we want to get the amount of the total amount of regions that it is under? Not D now. We're saying, what if I want to represent this N to the total amount of regions in the entire block? What would I do? So to get the total amount of regions, we would, and I want someone to raise their hand. Let me just see. Don't raise your hand yet. Let me just look at it. All right. Starting now. First person to raise it, get a point. Pale. All right. I see you. Pale.
Add.
Yes. What would we add though?
The number of blocks.
Excellent. We would add. So let me put pale. Put pale right here. Pale. There we go. Excellent. So pale said we would add the amount of blocks. And that's correct. Right? Because if I want to know, for example, how many does Athzura have, I would count 1 for Athzura, then I would count how many blocks there are. So I would say 1, 2, 3. So therefore, Athzura has a ratio of, one moment, Athzura would have a ratio of 1 to 3. for example, 3 is the total amount of blocks. Excellent. But there's something wrong with my diagram, and here's why. Is it a case where all the blocks are equal in this diagram? No, it's not equal, correct?
Yes, sir, it's not equal.
Right. So that means, therefore, that if I was to say that after 0 I got 1 out of 3, because it's only one shaded block, that would be incorrect, right? Because she didn't just get a 1 out of 3. If you look at the diagram, she got a half, right? But based on the rule I just said above, if I count the amount of regions that she have shaded, it's only 1. So there's a rule that we need to understand. All blocks must be in equal area for the ratio to be true. Let's write that. All blocks, this is very important, all blocks must be in equal area for the ratio to be true. So if I wanted to express that after 0 had half of the entire gold, which is, I don't know why she would be so happy to take so much, but we would need to represent it on a better diagram, right? I'm going to ask the question now. Don't raise your hand yet. How could we represent, or what could we put on the diagram to show that after 0 has 2 sections, not just one large one, that would represent the ratio correctly? Let me see the hands. 1 second. All right. I didn't see who raised it first because I just joined down. Who raised the hand first? Honestly. All right. Ready? 3, 2, 1. Raise your hand. Pale. Saw pale hands first. Okay, pale. What could we do now to show that this section of the block is equal?
You could draw a line in the middle.
Right, let's try that. And let's see if she's correct. So if we draw a line in the middle, and that means we now have 4 sections. And yes, she's correct, because now we have 2 regions that are shaded for after 0. And that would be now 2 to 4. Excellent. Good job, Pale. Pale. Okay, good. All right, so now I'm going to ask another question. And Pale, let's try to get someone else now. Explain to me how much she would have. How much? Explain how much blocks does Ath0 have? Does Ath0 have green shaded? And simplify if possible. Simplify if possible. Right. Let me look. Don't raise your hand yet. Let me check. All right. 3, 2, 1. Raise your hand. Jazeel, I saw your hand. Okay, good. How much does Ath0 now have?
So she would have 2 over 4.
2 over 4. Okay, but could that be simplified? So you say we have 2 over 4 or 2 to 4. But could that be simplified?
Yes, sir.
Right? What could it be simplified to?
1 over 2. 1.
Right. When simplified, it gives 1 over 2, or the big answer, 1 to 2. Excellent. And that is correct. So that is the real introduction to ratios. Right? Everybody understand?
Yes, sir.
All right, good. So we can close this up because we know what is a ratio now. Excellent. Let's move on now and talk about, because we just did the ratio review, ratio example. We're going to do a ratio as a decimal or percentage. How could I represent that Ath0 has a half as a decimal or a half as a percentage? Quick review. So we're going to go now to the book 2, page 111. If you have the soft copy that I gave you, it should be 115 or so. But just quickly go there. We're going to talk about a ratio as an equivalent decimal or as an equivalent percentage. What does the term equivalent mean? Right? Anyone but Jaziel and Tail. I want to have more people participating because the more times you answer, the higher you will be on the leaderboard and the points will be updated today. All right, raise your hand for me. Raise your hand. Let me just check. After 0. Excellent. What does equivalent mean?
Equivalent is like equal to in a way.
All right, let's check.
But it's not necessarily equal to.
All right, so
I guess it could be another way to represent something.
another way to represent something that is equal.
Yeah.
All right, excellent. And I think that is correct. That's excellent. All right, so 1 point for after 0. There we go. Good. So if we talk about equivalent decimal, then that means that decimal is equal to the ratio. Equivalent percentage, that percentage now is equal to what we had as a ratio. Right. So here's a task. Before we even go into the topic, we're going to finish what we started with after 0's share of the goal. She had a half. I want someone to represent this half as a decimal without calculating it because it should be on the memory, as a decimal and as a percentage before we even go into how to do it. All right, it's a very simple one. Raise your hands. Anyone both at 0, Pale, and Jaziel? Harry. Are you there? Nicholas. I see you, Nicholas. Good. All right, Nicholas. How would we represent this half as a decimal?
As a decimal, that'd be half would be 0.05.
Let's see. Half is equal to
0.05.
0.05. All right, that's a good guess.
100 would be 1.
Okay, so tell me to your reasoning.
And,
so
like if it was a whole, that'd be 100.
Okay. All right. So let's see if we can put it on the right path. So you're correct in terms of the value 5, but let's look at why it wouldn't be 100 that we'll look at. Remember that the rule says depending on how much you have in the denominator, right? So if we had, for example, a larger value than just 2, then it would have been 100. But in this case, we only have 1 place here. So if we have 2 into 1, 2 into 1 goes how many times? 0 times, correct?
Yes, sir.
Yes, sir.
0 times. All right, good. What was the rule now that we did? After we put the 0 here, what was the rule? We put a point here as well. But what else? No, we didn't put a point, my bad. We put a 0 here, right?
Yes, sir.
Right. Then we said now 2 times 0 gives us 0 here. So we get 1 here. Then the 0 comes down. Then we say 2 into 10, 5 times, correct? Exactly. Right. So, Nicholas, you were correct in terms of the digit 5, but the reason why you moved the decimal place twice instead of once, because we only had 1. So you're correct in terms of the value. So I'll still give you the point. It's a little correction with the place, exactly. So, Nicholas, there we go. All right. So 0.5. Okay. How would we represent this as a percentage now, Nicholas? So we have
percentage.
Yeah.
That'd be 50%.
Exactly. So that's where your 0.05 comes in now. You see it? Because your 0.05 has 2 decimal places, and 2 decimal places is meant for percentages. So you got it right for the percentage. So you still get the point. Good job. Okay. Let's go into the topic now. So that was a little exercise, right? We're going to say now that we have someone that named Jim. So exercise 1. Jim won 10 cards. And Robin won 15. Question 1. We're going to do this together. Let's look question 1. How many cards did they win all together. Right. The word all together gives you a clue as to what you're gonna do. Together. Right? Someone? Who wants to work this question out? Let me see the hands. Let me pick someone. David, are you there? I'm just asking to unmute. David, are you there?
Yes, sir.
All right, good. How are you doing today?
Okay, sir.
All right, good. So if you remember from beginning, we talked about some keywords that would tell you that what operation you're doing. So if we have two persons and they're saying that how much did they win together, what would we be doing? We would
Add.
exactly correct. Good job, David. David. All right. So David says we're gonna add them together. So we're gonna say 10 plus 15 gives us a value which will be the total amount of cards. Good job. And that will be 25. That'll be 25. Good job. Next question. All right. What is the ratio of the number of cards Robin won to the total number of cards won? This is an interesting question. I'd like to see which person can think critically and tell me what the answer would be. Let's see who's raising their hands. See? Raise your hands. 3, 2, 1. All right, I don't see any raised hands. So I'm going to select Emma. Are you there?
Yes, sir.
All right, good morning. How are you?
Good, sir.
All right. So the questions ask you for two things. Let me highlight them for you. Firstly, ask you for the ratio of the cards Robin won, right, to the total cards won. Highlight them. All right. So firstly, just tell me, what is the rate? How much cards did Robin win? So we say Robin is equal to how much?
15.
15. And how much cards were in total from what David said? Total. Let me go back. Total.
25 cards.
25. Now express that as a ratio for me. Expressed as a ratio. And person doing it is Emma. Let's put your name, Emma. There we go. So express that as a ratio. You have something to something. How would you put those two values together?
15 to 25.
Exactly. And here's why. Because the question put Robin's amount of cards first, then it used the word to. So that means, that, in other words, this colon could be represented as 2. Right? Understand? So 15 to 25. Good. But are we finished yet?
No.
Right? What could be done to this ratio? Am I right? What could be done to this ratio? Right? How else could we visualize this answer? Use the word equivalent. What else could this value be really representing as an equivalent?
I think it could be simplified.
It could be simplified, exactly. Let's put simplified. That's 2 questions you got correct. All right, good. All right, so what could it be simplified to? So we have 15 to 25. It's gonna be simplified. Statement to the steps, right? Tell me the smallest number that could go into both 15 and 25.
The smallest?
Yeah.
5.
All right. How many times could 5 go into 15?
3.
3. And how many times could 5 go into 25?
5.
Excellent.
Times.
So that is now our simplified ratio. Thank you, Emma. You get your point on the leaderboard today. There you go. So the real ratio is going to be 3 to 5 when simplified by the factor 5. Good. Question 3. That was question 2 by Emma and question 1 by David. I'm going to go to question 3. Question 3 says, what is the decimal and percentage equivalence? This is a difficult question, so I'm going to ask 2 persons of the ratio, right, in part B. All right. So 2 persons, just raise your hand. Anyone? I see Jazeel. Anyone else? How about Pale? All right, good. Excellent. So I have 2 persons willing to do the hardest question. That means that they're going to get their best points. All right, good. All right, the first step we need to do, we're going to work on a decimal first. So you guys are going to work together and tell me now what should we do to get this value to a decimal. So let me write about the ratio, 3 to 5. What's the first step? Let's put step 1.
You put it as a fraction.
All right, let me put it. So you say declared as a fraction. Okay. Step 2. So let me put it as a fraction just to be safe. 3 divided by 5. Jazeel, step 2. Yeah. What could you do to this value now? So if you have 3 divided by 5, you could just work it out, correct, Jazeel? You could just say 3 divided by 5. So you could say 5 into 3. So you're going to do this long division for me, Jazeel. Ready? Are you there? Jazeel? Right. All right.
Sorry, hear me?
Yeah, I can hear you now. All right. So, Payal said step 1 is to declare as a fraction. So there's multiple ways you could do this, just to be safe, right? So if we're using Payal's step, your next step now would be to long divide this value for me, right? So you would say 5 into 3 goes how many times?
0.
0. Next step.
Put a point. No, yeah, put a point.
All right.
0.
Next step.
Then 5 into. Okay, so 5 into 3, you're going to put a 0 down at the bottom, sir.
All right. So you say 5 times 0, right?
Yes, sir.
And you put a 0 here. And what do you do to them?
Then you
add it, multiply it.
Add them, put back the 3.
All right, so it's subtracted here.
Subtract.
Right, subtract. And then now, because it's really 0, you can really just say you add 3 to it. So you just get 3 back. Right? And what do we do next?
Put a 0 down at the 3, make it 30.
All right, so I will carry that down. Let me put a red ink. Should I be carrying it down? All right, I'm going to put now 30. Excellent. So what do we say now? 5 into 30?
That was 6 times.
6 times. All right. Excellent. So what's the next step?
Then 6 times 5.
That will be 30, correct?
Yeah.
All right. And since we have two numbers now that subtract to give us 0, are we
just continue?
Right. So that would be 0 here as a remainder. So that means we're finished, right?
Yes, sir.
All right. Excellent. So that would be our decimal by Jazeel. Good job. Let's put it here. Let's put who did the work because I want to give you guys credit for your work. So here, Jazeel. All right. And let's put Payal here. So Payal, now you're going to take on the percentage now. All right. So step 3 is to, So the decimal, we just said it was 0.6. Everybody agree?
Yes,
Okay.
sir.
Right. Let's look at the percentage now. Are you there, Payal? What could we do now to this 0.6 to get to a percentage?
You multiply it by 100.
Excellent. All right. And a cool little trick, if you forget what you should do, Just look at this percentage symbol. It looks like a 1 in between. So we could say there's a 1. And we see 2 zeros, one on top and one below. So we could say just 100. So it's a little trick. Anytime you forget what you should do, look at the percentage symbol and look if you see a 1 and 2 zeros. And that's what you should do. So Pearl says we're going to multiply this by 100. And she's correct. All right? So that would be 60%. If we move the decimal place twice, it'll, let me just draw it quickly. Draw it. It'll be now 0.6. And it's moved. Let me use a red ink. It's moved twice. So we're going to say 1 here and 1 here. There we go. Let's put it back here. And then we have a 0 spot here because we jumped. And that would give us 60, which is our value. That's correct. Good job. So now what I want to do though, what if we have bigger?
Sir.
Yeah?
Very good. Do it like another way with a 15 over 25.
And that's what I was just going to say. Good job, Jesse. So I'm not going to talk. I'm just going to let you continue. So what are you going to say?
Then you would just like times the 50 by a number, which will give you 100. And that they could times 15 by 4, the 15, and 25 by 4. And the 15 will give you 60, and the 25 will give you 100. So
that is excellent. That is excellent. I'm so glad someone remembered what I was saying last month. So what he's saying is that there's another method, so we could call this method 2. Call this method 2, where Jazeel, let me put your name, Jazeel says we could multiply by a common number that will make the denominator as a percentage itself, which is 25 times 4. Excellent. All right, when we work that out now, we get 15 times 4 to be 60, and 25 times 4 to give 100. That will give us really the same thing as a percentage, which is just any number times 100, divided by 100, which is 60 divided by 100. That's therefore 60%. Excellent, guys. This was excellent. This was excellent. Okay, so that's really now, because I don't want to hold you up, because I know the class is over. So I'm going to do now, it's going to be the end of today's class. I'm going to put the work on the portal, because if you still don't have the book, I want to ensure that you have. So you're going to go on Activity 5 and do question 1. All right, question 1 has 2 parts. Repeat?
So which page can I find it, sir?
112 in the book 2. All right, but I'm going to give...
Sir, give me a soft copy, sir, and I cannot find it. Page 112.
Right, so let me write it. Page 112, question 1, A and B. All right, I'm going to put it bigger. There you go. In the book 2. All right. I'm going to, if anything, I'm going to take a picture of it and put it on the portal as well, just to ensure everyone can see it. Any questions? Uh-huh.